Hello everyone. Now in this lecture we're going to answer at least two questions from problem set 1-1, which is in your chapter 1, lesson 1-1 of your book, Precalculus with Trigonometry. So the question is, it's an archery problem. So archery problem number 1. An archer climbs a tree near the edge of a cliff, then shoots an arrow high into the air. The arrow goes up, then comes back down, going over the cliff and landing in the valley, which is 30 meters below the top of the cliff. The arrow's height, y, in meters above the top of the cliff, depends on the time x in seconds since the archer released it. Figure 1-1g, you have the figure here. Okay, this is the figure. Shows the height as a function of time. So your height is a function of time, meaning that your h is in terms of t. So it's written something like this, okay? H is in terms of t. Now looking at the graph, letter A, what was the approximate height of the arrow at 1 second? So at 1 second, at 5 seconds. How do you explain the fact that the height is negative at 5 seconds? Now let's take a look. To evaluate the question, we are going to look at the graph. So as you can see, we have a graph here. We have a graph determined by okay, I think my pen is not working well. So determined by y, which is in meters, this is your height, and x, which is in seconds, this is your t. Okay, so what was the approximate height of the arrow at 1 second? So at 1 second, we're going to look at the point wherein there is 1 second. There is 1 second. So this one is the 1 second, this one, right? So let us just draw dots leading to this point. So at this point of the graph, let's make another color for that one. So at that point of the graph, what is the approximate value of your height? So at let's say h of okay. I think it's more accurate if we use y. Okay, if your y of 1 second, which is y of 1, is equal to 20 meters. How did I find 20 meters? Just by looking at the coordinates. Just by looking at the coordinates given by this. So at x is equal to 1, your y is equal to 20 meters. Now how about at 5 seconds? So at 5 seconds, so that's y of 5. Now these enclosures here, this parenthesis here, does not mean multiplication. It just serves to show that that's a function of the certain variable here, which is y. So meaning 5 is a function of y. It's just substitution. You're substituting x values to get the y values. So at y is equal to 5, where is y equal to 5? Where is x equal to 5 seconds rather? So you can find it here. This is 5 seconds. So just draw a dot. It should be, okay, let's use this. It should be this, and here. Okay, so that would be here. So y of 5 is approximately negative 15 meters. Okay, now there is a follow-up question. How do you explain the fact that the height is negative at 5 seconds? Okay, going to the realistic sense, note that you are up on a tree, you are somewhere upper from the ground, and then you shoot an arrow high into the air. So the arrow will go up and then go to a certain valley. There is a cliff, and the arrow overrules the cliff and then goes down. So of course, before a certain time, let's say here it's 6 seconds, the arrow will go through the cliff, right? So that's why at a certain time of t seconds, and that's 5 seconds, we would expect the arrow to be somewhere negative, meaning that it's this line here. Okay, to put it simply, this line here is the ground. Okay, this is the ground. It's the ground level. Now, if you have a cliff, the arrow will go to a certain height which is lower than the ground, and that's negative 15 meters in this example. Okay, now let us have another question. So the same problem, number 1, archery problem 1. Now it's letter B. At what 2 times was the arrow at 10 meters above the ground? So 10 meters above the ground. Let's look at the height 10 meters. Okay, where is the height 10 meters? It's here. It's very thick. Okay, let me have, okay, this one. This is 10 meters. So it's here. Now, as you can see, there are 2 time there. We have this thing here. We have this part here. And we have another part which is approximately 4 seconds. So at what 2 times was the arrow at 10 meters above the ground? This is approximately, well, this is y is equal to 10 meters. Okay, 10 meters. So we have point 1. We have this point, and we have this point. So y of x1 is equal to 10. Now there is another x2 wherein the value is also equal to 10 meters. And looking at the graph, x1 would be equal to x1 would be approximately, let's say that's 0.2 seconds. Let's just approximate everything, okay? They're not looking for the exact value. So x1 is equal to 0.2 seconds, which is here, 0.2 seconds. Okay, and okay, it should be second. That's a grammatical error. Okay, 0.2 seconds, and then we have x2. x2 would be the point here. So look for 10, and look for the corresponding x value for 10, which is 4 seconds. So this answers the question for letter B. Oh, we have a follow-up question. Okay. At what time does the arrow land in the valley below the cliff? Now, to find the time when the valley or when the arrow landed in the valley below the cliff, we have to look at this value here. Now, when it stopped, it means that the arrow already landed to the valley. So this point here, okay, that point means that you have a y of what is our y there? So for the second question, okay, question 2, we have a height of y of equal to x3 is equal to negative 30 meters. In that case, our x3 is approximately, what is our x3? It's approximately 5.2 seconds. So 5.2 seconds. Okay, so these values answer our questions for letter B.